So, were you going to present this, Vivian? I thought I was going to present this, but I don't know.
Oh yeah, I also thought you were going to present this.
Oh, okay.
Okay. Yeah, I wasn't
I don't
sure.
even know what
Okay,
exactly
great.
you
I
would
don't know.
present, so
Yeah,
All
okay.
right.
It's sort of the opposite end of the spectrum. Uh, Vivian and I were talking over the last week and few days, and I put together a list of things that I've been thinking about, and I realized at some point that they may all be related, and so I just put them on a list. And these are problems that I think we have to address. Um, and they're not none of them are new. You've heard them all before, but I'm putting them in a list, and we can just briefly discuss them. Um, I think none of this changes anything fundamental about what we have in the thousand brains theory, but this it could lead to changes that could have a lot of implications for code, for example. So I don't want anyone to get spooked by this, but I don't think these are all like refinements of what we've done so far and things we haven't really addressed. So, as we go through the theory, we try to tackle one thing at a time. Let's figure out sequence memory. Let's figure out, learning of static objects. Now we're thinking dynamics and so on. Now we're going to do causal behaviors. But as you go through this, there's always little things on the side. You go, well, we didn't quite understand that. We'll come back to that later. So this is a list of those things that we didn't quite understand. And I think it may be time to come back to them. So with that preface, I'm going to share my screen.
and I guess it
Um,
might also be quite big changes to the theory around object behaviors, like which isn't implemented in the code yet, but um, I guess like if we think now about object behavior models, maybe encoding the movement of an entire object and maybe the interplay between behavior and morphology models being different
right,
and
right,
states
right,
and all that. So
right. It could have a lot of impacts, but I just want to stress it's not like throwing away the theory. It's more like, yeah, we didn't deal with these issues, and now maybe it'll change the way we think about things. Um, so let's just go through it. There's no great depth and thought to this. I just made this list. I didn't spend a lot of time tweaking the items, so we can just discuss them as we go. Number one, I assume everyone can see my screen now, is shared learning. This is the problem that, it's easy to understand how a single column could observe different parts of an object and build up a model, but we need to have lots of columns do this in a region. And our basic assumption is that all the columns in a region have to learn the same models. And really the advantage of having this is faster inference. That's really the only reason that you have many in the same region. So you can do this sort of flash inference. It's much quicker than serial inference. But it's always been a problem. Like, do we really expect every column to see every part of an object? Um, it got really intractable, excuse me, when we started talking about behavior models, because in behavior models, we don't even have time to move over to the object. We don't have time to observe different locations. Um, it was all of a sudden, oh crap, we can't ignore this anymore. There's a problem here. There's something wrong that, how is it that we all these things can learn so quickly? I still assume they're all learning the same things, but there's something wrong about how either we think about learning occurs or about the representations in columns that that we don't understand. So that's what I mean by shared learning. Um, if you have any questions about that, speak up now before I go on to the next one. All right. I assume that everyone understands that problem. Um, we have another problem, voting with relative pose. Uh, this is the idea. We know that for our flash inference to work, the columns need to know the relative pose to the object. Um, and we don't really have a good solution for this yet, at least for the brain. I know we have an implementation in Monty that works. Um, we talked about how that there's some sort of a consolidation time during like that, you'd be playing back sequence of previously learned or experienced um, stuff was like during sleep, the hippocampal might play back. And so everybody could be exposed, all the columns could be exposed to the same sort of learning sequence at some other time. That might work. Um, but it seems to have sort of limited capacity. We were talking about this in the brain. These little sequences are pretty short. They have to occur during, half a cycle of like some frequency, and so you can't get a lot of playback that way. Um, I just want to point out that I just don't feel we have a real good sense of this yet. Um, I don't feel comfortable. Something about this feels still odd to me. Um, so again, we have a working solution in Monty, so it hasn't been holding us back. But as always, I always worried about that we have a working solution, but there might be a different solution that is theoretically much more important. Um, and so that's something to be considered. So, any questions about that before I go on?
I guess maybe one thing is the potential alternate solution we discussed, the playback, could be a solution that helps with number one, the shared learning. If we can play back observations we had at different locations at one time, too many columns at once, it could help with
Right,
the shared learning problem.
right. That's right. Although, again, when I started thinking about behavioral models, it felt like I wouldn't even be able to experience it one time for a single column, so that it could be played back. It's like it would be like the problem got much more intractable. It felt when I started thinking about the behavior models the way we thought of them.
Yeah, it'd be more
Because
like you have five columns that observe the behavior on different locations. And then those five can replay their observed changes to all of the other ones
right, but then
afterwards.
you have
But
to do it
five
one at
might
a
not be enough for behavior.
right up
So
enough, and then you have to take turns. Who's going to play back first? And who's going to play back second? Because they all different learning experiences. Anyway, it just felt like complicated. It's like this feels too complicated to me. Um, But again, we don't know the answer to this. But it's a good observation. It would help with the first one, perhaps. Um, the next thing is the number three we've talked about also, and I've been really kind of sort of pushing on this direction, is in the brain, of course, we have the hippocampal complex, which does fast learning. It has episodic memory, that's fast learning plus time in some sense. And we contrast that with the sort of cortical learning, which is very slow. We think of it more of a static models or models that change very slowly. Um, we know that much about how we work with the world requires every moment to moment we have to do this sort of fast learning. We don't know how much fast learning might occur in the cortex from some parts of the cortex. Certainly, we think some parts of the cortex don't learn fast at all. Um, so, how do these two work together? And it's sort of like the models in the hippocampal complex and the cortex seem to be seamlessly combined. And I've talked about this as like I can have um, an object that even something like the stapler, where I know I left it in the open position when I left the room, and I come back and I expect it to see in that position. That's not a permanent model of the stapler. That is not how the stapler always is. It's just like right now, that's what it is. And later it'll be something different. And yet it's involving the stapler model. It's not like a separate, the hippocampal complex isn't working on its own. It's sort of like models get combined together. So at any point in time, there's a static portion of it, and then there's a dynamically or recently changed portion of it model, and they can't work the same way. So we talked about how these could be combined somehow. We even talked about the idea that they might lock into the same reference frame between, a sort of column equivalent in the hippocampal complex and a region. So that's really this integration of these two things is really, really critical and to do anything useful in the world. It's also an interesting question to say, does this separation need to occur in Monty? This could be done purely because um, brains aren't very good at, neurons don't like to learn quickly. And so you have to go out of your way to get them to learn quickly. And so biology may have separated these two things out like this because you can't have a lot of neurons that learn quickly. It's just too much neural tissue. So um, I don't
I
know. I
guess,
think we should understand it first.
right. I guess one other thing with the hippocampal complex is, of course, its involvement in episodic memory, which is
Right.
kind of tangled up with fast learning. And
Right.
so, we probably don't want all learning modules doing episodic memory. So, like, we'll definitely have something that's like
That's a good
specialized.
point. That's a good point. Right,
But it could, yeah, maybe still reuse a lot of the kind of
right, right.
uh, hardware architecture or whatever of the learning modules.
That's an
Or I
interesting
mean,
question.
it doesn't necessarily need to be like a specialized hippocampus learning module. I was thinking of it more as like a parameter that can gradually change. So, for example, if prefrontal cortex, you can also learn faster. And Subota mentioned to me recently that they actually found these silent synapses in the cortex now as well. So it's not just in the hippocampus that you can do the fast learning,
Right,
but
right,
you don't want
Right.
to do it at the lowest levels. So it's more like maybe like a thinking of it as like a gradual uh,
right.
changing parameter.
Suicide told me those things too, and I read some of those papers, and it wasn't quite as exciting as he made it sound. At least it didn't appear that way to me. But there's some truth to it. But it was like I think he oversold it a little bit. Um, anyway,
Okay, yeah, I didn't have a
yeah.
chance to read them yet.
It's it's true. So these are just questions, right? It's interesting. I mean, it's interesting question also. Just we haven't really talked about episodic memory too much and how I haven't thought about it too much about how important that is to solving problems. Um, and it seems like probably it would be. But
And it
episodic
feels
memory,
like a very different representation of time from what columns use.
right? Yeah, totally. There's
That's a totally different, yeah.
right,
It's much
but
more kind of a, yeah.
right. So the question is like, do I need episodic memory um, to go in the kitchen and make a pot of coffee? Maybe I don't know. I haven't thought about that much. It's like I definitely need to know. I have to have temporary memory. Oh, I observed this here. I observed this here. I observed this here. But do I need to know? Oh, I observed this here 20 minutes ago, and I observed X here 2 minutes ago, and I walked to the bathroom in between. I
I
don't
think
know if
there's
I need
definitely,
to.
yeah, I think there's definitely a lot of interesting problems that we'll only solve with it, but maybe also a class of interesting problems that you don't need it. So yeah, I guess
Right, right.
it can be deferred.
Well, I don't know if it could be the first. My point of listing all these things, the end result of all this is that I think many of these things I'm talking about right now can all be solved at once. I think they're interrelated in some ways, especially when it comes to attention and a few other things. So there's a glimmer of hope that these things are all related, and that we've got something wrong about how we think about space and how we think about reference frames and we think about something attention windows. So
Because
I'm
even
holding
the third one feels connected to the first two. Like
right,
with
right,
doing the serial thing, we've talked about how that could involve the hippocampus, and of course that could then be used for replay for shared learning.
right. So um, that's why this list. I think everything on this list is potentially related to the other things on the list. And I feel like there's maybe one or two things that we just haven't gotten right yet. And if we just reconceptualize or thinking about something, this stuff will become clear. That's the hope, at least. So that's number three. Um, the number four is attention, and I spent a lot of time thinking about this so far. I haven't presented on it yet, um, but this is an important concept that we don't just observe the world; we observe attended regions of the world, and these attention windows are clearly 3D. At least they have a depth element to them. I think I've concluded that they may not be 3D, but they're at least 2D with a depth, which isn't necessarily 3D. It could be a 2D thing at some distance. But 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 it's obviously very important to how we perceive, how do we serially go through things in the world, and it's a way for different parts of the brain to tell other parts of the brain what to do, and where they should be doing it. And it's going to be related to both perception and inference, and it's going to be related to motor output. So we need to integrate the concept of attention, attended regions. I mean, regions not like cortical regions, but regions of attentional space. We don't have a concrete theory about how it's done yet, how it's generated, by which regions, how it works across regions, between the hippocampus and the cortex. But it's a pretty fundamental thing. The thalamus has been implicated in this for many years, um, and uh, and we've kind of danced around it, just saying, "Oh yeah, well, attend to this area here." But we need a more theory. I don't think this theory is going to be too complicated. It's just we haven't done it, and so there's some questions about how is it specified, where is it specified, who's creating it, how different parts of the brain compete with ascending what's attention. And the attended areas are also clearly bottoms up and tops down. There's non-model based, model-free attention, and there's also model-based attention. So this is an area, it's sort of an add-on to our learning modules, an add-on to our cortical theory that we haven't really dealt with yet. Um, and of course, it's going to relate to learning too, because you only want to learn the things that are in the intended area and so on. There's a whole the class. I haven't put any text under this, but the word classes. Um, we we don't. Vivian sent me a link this morning. I haven't read it yet. Vivian, sorry. I just saw it when we started this meeting. But in my mind, it's still an open question about how do we recognize objects that are similar but not the same, and how do we define what classes are. I was reminded of this when we were talking about uh, behavioral states, and we were debating whether behavioral states exist, uh, um, you know, completely independent of morphological models. Is a hinge behavior that applies anywhere, or as I suggested in a post last Friday, that maybe behaviors are assigned to a class of objects. And that even brings up the idea that maybe classes of objects are defined by common behaviors, uh, which is like a different way of thinking about it. It's like, oh, these are in the same class because they share a behavior. And then an object could be in multiple classes depending on which behavior you look at. So I think that's an idea we brought up once before, but I forgot about it. And it came up again when I was thinking about this, that,
Yeah, so the link I sent was we discussed this in January in a research meeting about classes, and kind of the idea we walked away with at the end of the meeting was that we could leverage the fact that different columns will receive different input, and especially at different levels of the hierarchy, they will receive different granularity and different type of information. So they'll naturally learn kind of more classes of object at higher levels in the hierarchy. And it would fit nicely with this idea you just mentioned about behaviors defining classes, which is if you have a kind of compositional model that's defined by behaviors that exist at different locations on an object, then all the objects that this pattern recognizes or this model fits onto would be the class of objects that has those behaviors, essentially.
right. I'll have to go back and look at those notes from January, but um, it
Yeah.
sounds good. Uh, but it's really important because we have a great theory about how we learn detailed things like the mug with the logo at a particular angle and it's curved, and I mean that's pretty detailed. I mean, we have to have models that do that because as we can make a prediction about something, we have a model of it. But we haven't really incorporated this concept of classes completely or even at all. So I think the stuff that Vivian mentioned, I mentioned, it could really help us get a grasp on that. Um, so I do like the idea that behaviors could be how we define classes. It's like if an object seems it provides an affordance to do something that another object has, then we could say, yeah, well, they're in the same class because they both do the same thing, as opposed to they both look the same. And that's a powerful idea. So we have to develop that as well. And then number 6 here, um, this is a bucket. It's like basic modifications of our column learning model. Uh, During our Milan meeting, and then afterwards we talked about it here in research meetings, Vivian made the suggestion that we were thinking about behavioral models wrong because we had this idea that behavioral models, just like we have the idea of morphology models, you have some sensor and detects something, and it says, "Oh, there's a movement out here. That's a feat. That's an input to this model." It's like instead of detecting an edge, it detects a moving edge. And we ran and realized that wasn't going to work when it comes to movement. And so then Vivian suggested, well, maybe what we really need is has the movement of the entire object or child object, which means the movement of an attended area. So the child object would define an attended area, and then we would say, what is the movement of that attended area? We get this information off the retina, and so that was a nice solution to that problem. but it made me think, whoa, that's a fundamentally different way than I've been thinking about it. And maybe that same idea applies to morphology models. Like, why wouldn't it? And so if I'm if I'm somehow encapsulating a movement of a child as a whole, and I'm doing that using, an attended region and processing information from the retina, for example, maybe I'm doing something similar in morphology models where I don't want to just attend, I want to attend to some region. I want to somehow encapsulate the orientation or the some other structure in that entire region. And this led to the idea that I'm not suggesting is right, but I put here anyway. And I talked about it the other day. Um, uh, well, I think I say it right here. So this is like um, the idea that maybe a column is not just looking at edges all the time. Like, that's maybe what somehow it's able to, our current thinking is the spatial pooler takes a bunch of inputs and just produces an orientation. But maybe there's something more going on. Maybe there's more of a sort of there's no reason that the spatial pooler under different conditions wouldn't learn more of a prototype or prototypical, or I wouldn't say not prototype, but a more complicated spatial structure. Right. We've always assumed that the only thing that we can get off the retina is a sort of oriented edge or an orientation. But the spatial pool, if you give it a bigger set of bits over a larger area, would learn, and you give it enough mini columns, it would learn more. It would learn higher level structure. That would not. It would not be a sensory motor learning. It would be a spatial pooler learning, and therefore it wouldn't be orientation invariant. Um, but it would be quick and fast. And so this is a very fuzzy idea here. But it reminds me of the fact that we don't really understand how a column learns simple things like a circle or an oval. We kind of can say we do, but I don't think it really. It's just there's some problems there. It's just way too much learning. It requires too much precision um, between the different, the learning modules. Each is seeing some portion of something. It feels like something else is happening when we think about that problem. So then I said, just let me ask if the spatial pool could be recognizing more complex spatial patterns. Um, and since some columns might learn and for a more complex spatial structure without movement, this would have limited capacity and resolution. Um, but the idea is, a column might say, oh, I don't just have this like teeny little thing. Maybe I have some more structured spatial input I have. And then on top of that, I can do a child by child um, inference or, search. And so like when I flash something in front of you, your brain seems to have um, a very instant sort of percept of some structure there that's not just it's something that I seem to recognize. And then as I go around and look at the individual items, I fill it in. I feel that when I'm looking at an intersection. I feel like if I flash the intersection in front of my face, I can somehow sense it's an intersection, but I don't really have any of the details. But then I'm somehow able to then look at, oh, there's a car here, this here, and this, and there's a sign I know there, blah, blah, blah. Um, it's a fuzzy idea. Um, but but I think it's worth pursuing to think
And I,
about it.
I would say maybe it's not necessarily something that would have to be a basic modification of the learning module model, but more of a supplementary mechanism that makes it a bit more powerful because you get more informative features as input. So like
Right.
it doesn't remove the need for reference frames, for example.
No.
You
Right.
still
Right.
need to have the whole mechanism we have of having storing features at locations relative to each other and integrating movement over time, but it would basically give more expressive features as input. And
Right.
so the shared
It,
learning or voting might be a bit simpler to solve.
these are, I think that's worth emphasizing again, what Vivian just said is that this doesn't throw away anything. It's just sort of, it's like nuances or refinements of things we assumed. But right, I mean, it doesn't get rid of the reference frames in any sense at all. It reminds me of, it's like when we learn a word, right? Um, there's two ways of training kids these days. But we all end up in the same place. One way you start with like, oh, here's a word, we're going to learn one letter at a time. And now that's how I learned. That's how everyone learned in the past. But now there's some schools that teach like, no, don't even worry about that. Just learn the whole word and don't learn how to spell it. And we all end up in the same place. In the end, when I'm reading, I don't look at all the letters. And if a word has basically the right shape, right size, and sort of the right shapes on the ends, and I'll see it as a word, even though it could be misspelled in the middle. I don't catch that unless I look at it, attend to it. So there's this. We can even see this in reading something like a word, that there seems to be this. We have both the compositional model of the world, which is letter by letter by letter. I know that, but there's also on top of that, I somehow have learned the Gestalt word, which is more of a spatial pattern. And I would, if this is what I just said was true, I would imagine that Gestalt would get much poorer if I was trying to read, upside down or read vertically. Whereas if I look at letter by letter, I don't have a problem with that. Um, so there's,
Although I feel
there's,
like, yeah,
yeah.
expecting the spatial pooler to learn patterns for all the words out there is maybe pushing it a bit. Like I feel like that's maybe still something where voting comes into play, and maybe the beginning and last letter are more important in that process. But it feels like having to learn the hundreds of thousands of words and how they
Well,
look
we don't
like.
we don't learn hundreds. I don't think we learn hundreds of thousands of words that way. I think we learn simple words that way. But if I see well, it's also maybe I do. It's also we also have to rely on the fact that we have a huge amount of context when we read words, right? Um,
Yeah.
and so I think um, you know, take two words. I don't know. I'm making this up. Incriminate and increment or something like that. They may be similar in many ways. If in context, it's very clear which one I should be seeing. I almost predict the word before I see it. But out of context, I might make a lot more errors if I just had to, read it very quickly in some sequence. Again, you're right. I'm not even suggesting I know the answer to these questions. These are just ideas that are sort of popping up, but I feel there's something missing here. I feel that we need to explain how it is I can recognize an entire word at once, and I can do that in V1, even if it's a simple word. Um, and it could be through voting, but it's like, right, what am I voting on, right? This, by the way, gets back to the issue of pose. Um, this idea that if a spatial pooler did what I said, there's no pose invariant into this thing, right? There's no ability to um, and anyway, the spatial pool doesn't have that ability. It doesn't do orientation change. I should say orientation changes. So where was I going with this? Oh, anyway, so if I were if I had a bunch of columns that were all trying to um, infer some raw spatial structure without temporal or movement issues, um, they could vote on that without knowing necessarily if they're all looking at the same thing, all trying to infer the same thing. Then they could vote with perhaps without knowing their relative pose to each other, um, where the relative pose would be less important, at least in that case. Anyway, these are just the, this. There's no solutions I'm presenting here. This is a list, a proposed list of problems that I sense are all related, at least many of them are, and that there's a potential we could solve them, all of them, or at least a good portion of them, with one fell swoop, thinking about attentional spaces, thinking about changes, how we think about the spatial pooler or something equivalent to that, um, thinking about, they seem to be related. And when we come up with a solution to them, we might problem solve our shared learning problem, because we realize learning isn't exactly what we thought it was before. We don't have to do as much of it. Um, that's it. I don't have any proposed solutions but anyway, these are things that I've been thinking about. We've all been thinking about. I spend more time on it maybe than others, but maybe not. Um, and I had the sense like, okay, and the reason we got here, because Vivian and I were debating the nature of states and behavior models, and I felt like, okay, we got to be careful that we don't solve a particular problem when we're missing there's a general solution to the whole thing. And I think might be a good time. This might be a really good time to sort of tackle all these at once. I think we have enough pieces in place and enough. Everything about our learning modules in some sense correct, but there's something wrong. There's something addition that has to be added to it. We didn't include these things, like attention. And so anyway, that's all I have to present today. It's just like, hey, there's a promise we could knock a bunch of these off at once, and that would be really cool. Um, and I don't want to think
Yeah, I think
about
it's interesting to think how they're related.
right.
One thing you might be interested in, I can just briefly share, is
I'll
we've
stop sharing
been
them. You want to share? You want to
working.
share? You want to share your screen or no?
Sure, yeah. Yeah, but just to say, we've been working with some students and a professor at Penn State University um, to basically get richer features for input to Monty, into input to the learning modules, and in particular, kind of capturing sort of texture in a model-free way and a way that's rotation invariant. So it's not doing everything you're describing, but it's certainly related. So I just thought you'd find that interesting. But so it's using this classic technique from machine computer vision called local binary patterns, which was like an old school way of kind of classifying images, um, which ultimately is relatively, you know, is limited when you try and classify like someone's face using this, but it seems to be pretty good and pretty powerful when classifying something like textures, and is interestingly fairly brain kind of biologically plausible. But basically, if you take an image with all the pixel values, what it does is you kind of go through, you kind of convolve through, and you look at every central pixel in like an array. You basically say, okay, are the pixels around it lower than or greater than that pixel? So here it would be a bunch of zeros and a bunch of ones like this. And then that sequence, which is ordered from, let's say, the top left corner, forms a binary pattern. And then you can turn this into a unique integer that captures that binary string. And then what you can then do, so then if you imagine doing that several parts of the image, you get these different patterns like this. These would be associated with different integers, and this gets reused every time you process an image. But basically, then any given image, let's say 64 by 64, 120 by 128 pixels, will have kind of a histogram of incidences of these different patterns,
Those
and that
patterns, but
becomes
those patterns aren't rotationally invariant, right? They're not
not right
because
now.
yeah, okay,
But what you can
right.
do, what you can do is you can basically say this, let's say this string,
Mhm.
you can do nine or eight rotations of it. And if you basically say those eight rotations are equivalent, then it is rotation invariant.
Okay, right, sure.
Um, and that actually condenses the code a bit. And then the histogram kind of becomes, yeah, sort of like the fingerprint for a particular texture. And so different textures like these will then result in different histograms, and then you can use kind of distance metrics to compare like a stored histogram versus a received one. Um, but I think it's kind of, and yeah, and in general, this seems to work pretty well. Again, if you're just focused on like so one of the nice things, so I already mentioned how it can be rotation invariant, but it's also fairly robust to changes in illumination as long as it's uniform within the patch, within the kind of the image that you're concerned with. Because you can imagine if you increase the intensity of all the pixels or decrease the intensity of all the pixels, these relations will remain fixed until you kind of totally oversaturate or desaturate the image. Um, so it's also quite robust to lighting, and because it's not based on you know backprop or anything like that, you can quickly kind of as you were kind of learning, you could quickly lay down this histogram as kind of a fingerprint for that texture. Even if I don't know, let's say you've never seen fur before, you would immediately still generate kind of a meaningful histogram for that. Um,
Right.
and it feels similar, I think to like uh, kind of center surround,
Well,
kind
it's
of on
actually
off
it looks to me
receptacles.
it's similar to the spatial pooler in many ways.
And
I mean,
exactly, and similar to the spatial pooler.
I
Yeah.
mean, and I would say the spatial pooler is a more generic version of this. The spatial pool. I mean, first of all, we could separate out the fact that you're getting rid of getting rid of light intensity. So the retina has to do that, right? So So you don't want bright images to be perceived differently than dimmer images. Um, and the retina has multiple ways of doing that. And then I think the rotation invariant that they have sounds like it was added manually afterwards. Like they said, okay, we'll just assume these all can
Yeah.
be rotated. So it wasn't really learned. So the spatial puller doesn't do that. But what the spatial puller does says you give me any number of bits where I have on bits and off bits, or higher or lower, but it has to have some variation in it. Um, it would it will find and you give it it's just sort of an n winner take all. So depending on how big your n is, um, it will find a good set of basis vectors that represent that pattern you put it in. And if it's a small number of basis vectors, you'll end up with orientations of edges because that's the most common thing you can see in a small patch. But if you depending on what images you feed it and how many how many mini columns you have, um, it'll learn anything. We did this. We did this around Meta. It'll learn textures. It can learn anything. It just says, I'm going to do the best job I can. I'm going to represent this with n vectors out of, x possible vectors or n bits out of x possible bits that I'll learn the best basis set that could recreate that or at least represent that pattern. So it's essentially what they're doing, I think. In a very similar, different mechanism, but
Yeah,
same
I guess this one's
idea.
different because it's not as much there's not really learning going on in the same way. I mean, there's learning in the sense that we can take one of these sort of histograms and associatively bind it to a location in a reference frame.
How many
But
points? How many points in that histogram? How many? There's a
yeah, so it depends on a lot of things. But to give like depending on what parameters you choose, you can imagine maybe 100 to
well,
250.
I was just
Um,
looking at the histogram. It looked like I had maybe 100 or so bits in. I don't know,
yeah,
right?
but
Right,
then, for example, if you do the rotation invariance, that actually makes it smaller because a lot of those are
right,
redundant.
right, 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 right,
But then you can also do something where you look at pixels that are less than the central one. And so that gives kind of an extra degree of dimension, a degree of freedom, and that expands the code. You can also kind of like increase the number of neighbors you look at. That again expands
right,
the code. So it's kind of
right,
um,
right. So we did a
um,
lot of experiments with the spatial pooler with about 2,000 sort of mini columns or hundreds to up to 2,000, I think. And it was pretty good at all those things. I mean, it did a good job. And of course, then we applied it to sequence memory, and it was really good. And the reason we just don't do that is, we think about what we see in the cortex. If we think about a cortical column, we say, well, how many mini columns can a cortical column have? Well, a couple hundred. That's not many, and of those, only 30 or 40 are going to be active, something like that. And so you don't have a lot of, you don't have that many, you know. Well, it's not like you see that
right,
histogram there. It's like it's it forces a narrow set of active columns. Um, but I've always wondered. Then it's like I asked myself, I was like, well, what are the evidence we have that this is what's going on in other regions of the cortex? It's confusing to me a little bit. Like, what is the size of a column? And we think about it's defined about um, the area of the cortex. It all gets input from a common patch of sensor. That's how Mountcastle defined it. But do we really understand that? I mean, what do we really know about that? And what about higher up in the cortex? Could it be that we think that these cortical columns are small, but they're actually functionally much larger than we think they are? And that wouldn't surprise me in the slightest. Why? And therefore, um, it just wouldn't surprise me. So it's like I don't really know. We have really great evidence one way or the other. Uh, the evidence we have is from basically V1, V2 type of thing, maybe. But and even that's questionable because we think about the receptive field area. It's almost always in the context of very minimal inputs, sinusoidal gratings and things like that. Anyway, I think I'm not throwing the way. I'm not saying, oh, cortical column is bigger, but it is a possibility. in which case your spatial ruler could be much bigger too. And so we think, oh, there's a larger receptive field in V4 than V2, and larger than V1, but maybe that larger receptive field is actually the fact that we're got a lot more mini columns modeling some larger area of space. That's another opportunity to think about that. Um,
Yeah, right.
yeah, I don't know. I think these are all related, and it goes back to the idea that again, I'll just keep calling it Vivian's idea of the behavior column being sort of pooling over an attended area, figuring out. It feels like more could be happening in that area. We have an attended region, and we don't want to just look at all the individual parts in that attended region. We want to look at something more holistic in that attended region. And how could the cortex do that? Anyway,
I had some
Yeah.
thoughts like about that. Um, I put it in like a few slides. Maybe I can
sure.
share.
You just created them. That's pretty good.
Yeah, well, I created them like yesterday.
Oh,
So,
okay. Okay.
well, I saw your post on Friday. For some reason, like your in the research meeting, you posted something on Friday. I didn't, for some reason, I didn't like get it until Monday
That
afternoon.
was I think that was I did that Friday evening, and that was just the idea that behaviors could be assigned to classes of objects, in which case you could then, if a class
Right,
of an
right.
object is a morphology model, then you could put the behaviors back in the same column as the morphology model, which was where we started, but then we
Yeah,
abandoned it.
right,
But
right.
it doesn't, I mean, it doesn't work if an object has multiple behaviors, because you'd have to represent, like, right now, how we have it as the behavior is a child object on the parent morphology, not that they're equal. Or would you put the two child morphologies in the same column and it's the
I
behavior
don't
of the
know. I
child?
don't know. I don't know. I don't know.
Yeah.
It needs to be thought. But the point is, the observation was somehow now I want to associate a behavior with a class, and if the class, that's the only idea, and maybe I shouldn't have gone beyond that. Maybe going beyond that was a mistake. Uh, but then I was thinking like, well, because I was thinking, oh, isn't a class defined by morphology? Maybe not. Maybe that's not at all. Maybe that was a wrong assumption. Okay, so we can put what I put up there Friday night, maybe with a lot of question marks around it. Because good points, Vivian. I heard
Yeah.
you. Yeah. That's,
Yeah, I think I had a similar thought, or I gave a reply to that on Monday. I'm not, yeah, but I
you
had a
did.
similar thought
I didn't
where,
see. I didn't see. You must
yeah,
have done
kind of weird.
it.
I feel like
Was it?
some Slack messages are coming in delayed, but it's a
Maybe.
direct reply to yours.
When did you put that in there?
Probably Monday evening because I
All
saw it
right.
Monday afternoon. Um,
And you put it in the research. Where'd you put it?
well, in I think it was in research meetings. You posted something, and then in like the thread of
Oh, I
replies.
see right there. All right. Yeah, I missed that. Okay, sorry
Yeah,
about
but I
that.
mean, the what I'm talking about will be that, so you don't have to read it now. But basically, like um last week, like one of the interesting point was, at least to me, was like how, like at what level do we apply the behavioral models? And previously, like what you just said, like maybe you would need to kind of act on it at like a child object level or like an object class level, but something like a little bit more holistic than just feature set locations. So previously we had some, behavior models that store changes in like feature set location. And then this is kind of a little bit updated version from like Vivian's Excalibur, where last week or 2 weeks ago, you proposed something that where behavior model represents movement of a single child object. And so I was thinking maybe it'll be useful. So I think these are, it will be useful if we had something like a concept called, what I called an object skeleton, hence the title, is um, basically if the behavior models would like apply to kind of a morphology skeleton, instead of morphologies themselves, um, that might be useful for us in order to
So this is your
generalized
skeleton. Your
behaviors.
skeleton here is sort of like a class in some sense, right?
Yeah, I made a distinction between I call it skeleton, and I'm gonna make a distinction with class. Well, at least I think in my mind, class can be something different. So,
what would be different between a stapler class and a stapler skeleton?
not necessarily stapler, but think like I guess I'm thinking of object classes as more concepts. Abstract, like fruit is a class with apple and banana being so like instances. I'm not sure if we ever thought about class that way,
Well,
but
but that doesn't define what it is. I mean, is fruit a class because they have similar morphologies, they have similar behaviors, or just some in the case of fruit, it may seem arbitrary. Um, uh, I mean, the point is to define what is a class. I've always assumed that classes were somehow morphologically related, right? Oh, the different coffee cups are all coffee cups because they have similar morphology. But then we keep coming up with examples where that doesn't, it's hard to imagine how that's
yeah,
going to work. And so that there's an appeal like, well, maybe they're a class is something that's really related to behaviors, which is what you're showing in this picture, I think.
yes,
Well,
So
yeah,
I'm,
I think class is ultimately multiple things. I think that's why it's always been problematic to try and
right.
pin
So
it
I'm
down.
trying to
Like
separate them
class can be
out.
can be related morphology. Class can be the same behaviors. Class can be similar contexts like fruit, or I don't think
but
those
maybe they're
are
not.
mutually
I'll at least
exclusive.
throw out the challenge that maybe similar morphology. This seems like what it is, but what it is, the morphology suggests the behavioral abilities, and that's what makes them similar. You know,
Yeah,
a coffee mug, anything which has a handle and looks like it can hold fluid could be a mug, right? But it could look like a shoe. It could look like anything. But something that has a handle and can't hold liquid, it wouldn't be a mug. It just I don't care. It could be
But
right. But
Like
that's not
it's
what
not
I
it's
don't
naturally
feel
not
like they're
against.
mutually
explores.
exclusive though. Yeah.
Yeah, I think it's not exclusive from what Niels said, and yeah, that's kind of how I've been thinking of it as well. That there isn't anything special about a class representation. There isn't a column that's responsible for classes or a layer in the column that's for classes. It's more like every column learns about objects at different levels of granularity. It gets different input. So some columns might be modeling might have learned affordance models, and so whenever that affordance is recognized, that's kind of an object that has the class of this affordance of sitting on it or whatever, or grasping
Right,
it. Another column might be might get morphological features as input, and it learns rough shapes of objects, and that might be the class of round objects. And so, an object a specific instance of an object can be an instance of many different classes, and that would naturally happen because all the different columns that have learned very different models of the world would, like the round one would activate, the grasping one would activate when seeing this very specific round object. Um,
I don't know.
eh,
I'm not convinced. I'm not convinced of that. I think you can say this is a class of round objects. When I think about classes, it's always like I'm going to put a word on something and I see something, or I'm going to use something. I see, oh, this is equivalent. I can do this. I can use this thing for the same thing. Or what is it? Oh, that's a chair, or that's a mug, and I'm not sure I would extend it to things like round objects as a class.
but
I mean,
isn't
I
that
don't.
just learning an association between the model of an affordance to a word or the model of
Well, but what's the
morphology to a
affordance of a
word?
round object? I don't know. That seems to be not a class of
That you
objects.
can roll it, you can throw it.
Okay, all
Um,
right. Well, then that wouldn't be just round because I was thinking like a mug is round, but you're
but
saying
like
like a ball
when
shape or
kids
something like that.
when kids sort stuff, they sort it by all kinds of criteria. Like they sort by color, by shape,
Right,
stuff like
right.
yeah,
that. And it
yeah,
seems like you
yeah.
can
Maybe
categorize things in very different ways depending on
I
what your
think
goal is.
well, it would be. I think that's if it's true, it'd be less desirable from our point of view because it'd be very difficult to think of like. Then it seems like you have to have multiple mechanisms for figuring out what classes are.
No, I
No, it
think
Um,
would
that's the
be
beauty of it.
no
It
new
uses the
mechanism.
same no new mechanisms, and it's very
well, I
flexible
don't.
and
I right in the moment, I don't see how I can use morphology for class because we there's there's too many variations that don't fit a model, right? I have a model, my Dement or Thousand Brains coffee mug, and there's other mugs which just don't fit that model at all in morphology. It's how am I going to make it work? It's not like a
It would
fuzzy
be
version of it.
more at a
Um,
higher level in the hierarchy. Like for example, a place setting might be modeled at a higher level in the hierarchy, so it just gets object IDs at input. And so any cup and any plate and any fork will do for the category of place settings as long as they're arranged in a
no, but
specific
I
order.
got a bunch of objects in front of me, and I'm not a place setting. Just here's a mug, something else that's a mug. I got a bunch of my cabinet here. They're all very, very different. And I don't see how I could take the learned morphology from one or even come up with a common morphology in a reference frame that works for across those. It just doesn't seem like it's
So
possible.
I think you can get very far with morphology models. I agree there are also things where we want to use behavioral models to inform the class, like and affordance.
But
I don't think anyone's
I
disagreeing with
guess
that. But
right.
I don't see why we can't also classify
I guess I
based on
can't.
morphology.
I don't understand how it works. My understanding of how reference frames work and features, and it just says, hey, all the features are different locations. How am I going to see it's the same?
Yeah,
I don't know. It
that's
just
why I
doesn't.
feel like so this is kind of if we were to be able to learn some kind of skeletal morphology, then I get the proposal is that the behavior model acting on the swing morphology is harder to generalize. But if we were to act on this kind of simpler kind of skeletal morphology, then it might be easier to generalize. And that basically I'm turning the question of um, um, like generalizing behaviors as a different problem of trying to learn a different morphology representation. So we currently have like the point cloud, like 3D representation. We now just have like a way to learn like a 2D surface representation. If there is a way that we could learn some kind of more abstract object kind of skeleton or class or whatever you want to call it representation, then this could be a useful way for solving
Well,
some
why do you say
behaviors.
this cannot be learned in a sensory motor way? I mean, it feels to me if I was learning the morphology of a thing like a stapler, and
Hmm.
then I observed its behaviors, um, if I had some sort of class representation of the stapler, um, well, I don't know. I mean, they're learned together, so I don't. It's not clear to
Yeah,
me
there.
why cannot be learned sensory motor.
The
I think
skeleton is, I think that's what Hoji is referring to, that the skeleton couldn't be learned that way because you don't observe the skeleton itself in the world.
Yeah, that's
well,
right. That's
what if the way I viewed it is you can learn the behavior, right? We know we can learn a behavior, uh,
yeah,
uh, and then if that behavior is at the same time, um, uh, the whole point of my post is that if I had somehow a representation of the class of the object, I can associate the behavior with the class, and the class would be a sensory motor thing. I'm not, I guess I'm not agreeing 100% to that first point. Maybe it's true, but it feels like it could be learned somehow.
well,
Um,
yeah, maybe the point that you're saying is related like number three, trying to apply behavior model from one object to another. So in the stapler and laptop case that I showed, they are they have different IDs, but in behavior terms, they're both hingeable objects or openable objects. Like, and and if you look at the skeleton, that makes sense because we have kind of two lines where and those two lines meet at a point that we normally think of as a
hey,
hinge.
let me interrupt for a second. What I didn't like about that picture is like when I was thinking of like what's the difference in a laptop and a book and a stapler.
Mhm.
And it's not two lines like that. It's a 3D thing, you
Yeah,
know. And how do why would I think it's a laptop? Well, it has to do with the size of the surface area where the hinge is, the thickness of the object. How do I think a book? Well, the book has got it's sort of a sort of hingy thing on the left. It's a different size and has other morphological features that tell me it's a book. So when I was thinking about these behavioral models as part of classes, they would include morphological features that differentiate between the stapler and the laptop. Not just, it's not two abstract lines like you're showing it.
Can you
It's not
clarify
the
what you
deep.
mean by the behavior model, including morphology models, and then that would be a feature on the behavior model, or
No, I'm just saying is that again, if I somehow, again, I don't have the answer. It's like, well, why do I, if I were thinking that a book's behavior opening is not the same behavior as a laptop opening, which is not the same as a stapler opening, I wouldn't get that if I just drew line drawings like this. These very this idea that it is shown here. I would get that. I would know that these are different behaviors. One's a book behavior, one's a laptop behavior, one's a stapler behavior, based on some sort of the morphology of the thing I'm looking at. I mean, I could put a book next to a laptop, put the hinge on the same size, but I would immediately say, oh no, one's a book behavior, it has different behaviors when I open it, and the other's a laptop behavior. It's going to, and I can do that before I even see it moving. I would just know that these are different behaviors associated with these objects. So somehow the morphology of the thing I'm looking at, somehow in an indeterminate way, somehow the morphology of the thing I'm looking at dictates what the behavior is going to be. And in that case, a book opening behavior is not the same as a stapler or a laptop opening. It has to somehow include
well,
morphological features that let me say, yeah, this is in the class of book, this is in the class of laptop, this is in the class of stapler.
so yeah, I mean, it feels to me like that emphasizes again the usefulness of morphology models, but also that kind of class can be more just like what is the level of representation or abstraction in that a book opening and a laptop opening are both kind of hinge-like. So maybe there's a column that models hinge-like behaviors at a very abstract level, and it would see them as the same. But you'd have another behavioral column which would model book-like in more detail, and the idea of pages. Whereas with a laptop, you open it a little, and it hangs there. It doesn't
Right,
kind of
right,
fall
right, right.
down.
Well, I think
Um,
you're trying to have best of both worlds. I mean, we up to now we've talked about behavior models as being completely independent of morphology. They're just
right.
movement vectors. And I guess I'm exploring the idea of rejecting that idea, not trying to keep it, but rejecting it completely and
Okay.
say, no, there isn't a hinge um, behavioral model. There are books opening models. There are stapler opening models. There's door opening models. These models tend to be different, as you pointed out. They tend to actually have different motions sometimes. They have different orientations for sure, different sizes of objects they apply to. Um, and so I'm exploring. I'm just exploring it. I'm not saying we have to do anything. I'm just exploring the idea that there isn't a hinge behavior.
But
It-
so how are
Sounds
you going
good.
to deal with the kind of main reason why we wanted them to be separate, which is that a behavior can be on many locations and many orientations
well,
on different objects.
I'm questioning that because we we assume that you could have a generic behavior and it could apply to anything. And this
Well,
would
not
say that,
necessarily applying it to different objects, but for example, you can have three light switches on a plate, and you want to associate that switching behavior three times on the light switch plate, or you can have four doors on the car, and
well,
you
I don't
want to
think it's a problem.
associate.
I don't think it's a problem at all. I don't know how you reach that as a problem. It's just that I have a, I have, I can have multiple staplers in the world. It's not a problem. I can have multiple doors in the world. It's not a problem. Um, it's, I don't see that as an issue. Um, it's, we're taking one door at a time, one stapler at a time. It's not modeling four doors at a time. I can have one switch at a time. I'm thinking about that. Um,
But it isn't, I thought we said the behavior is always a change of a child object relative to the parent. So the rocker itself doesn't have the behavior. It's the behavior of the rocker changing its orientation relative to the plate.
right, right.
And
So,
so you
so,
can't really
right.
associate the behavior to the rocker.
But you can associate the rocker with its local environment, right? It's not the door, as we've always said, the rocker switch itself does not have a behavior. It has to be relative to something.
Right.
Um, um, but this is the fun, we've come up with examples where we've said, hey, maybe there just has to be something that the rocker is attached to, and that's good enough. I don't know the answer to these questions yet, but I think they're. But I don't see that as a fundamental problem. I think that's a clue as to like how do we get this to work in all these scenarios. Um, but
So
it
does
does
that
feel.
go back kind of to the idea that Niels and I were maybe going in the direction during Milan of having a like proto object around the rocker that is
I
independent
don't
of
know. Proto
this, like
object is the right
how
word.
this
I don't know. I don't know. It's I would have to think about it in terms of reference frames, and
Proto
I don't
reference
know the
frame.
answer to that. Yeah, I don't know. I don't know yet. But I think the point what I want to explore is the idea that there aren't generic hinge models, or at least that's not how it normally works. That there are lots of different hinge models, and I don't think that's a burden on the system to learn them. Um, and I think it's actually a big advantage because it turns out that things that have hinges actually don't share all the same behavior. The behaviors vary. The hinge on a book works differently than the hinge on a door, which works differently than the hinge on a laptop, which works differently than the hinge on a stapler. And so I like this idea that behaviors are um, tied in some way to classes or morphology, or there's not a generic one. And I
Well,
don't,
and what's the issue of having both? Like that we'd have more specific behaviors and
well,
more
it
abstract
just,
ones?
well, I don't know why I would do that. I don't know why I would want to do
Because
that.
then you
yeah,
could
but
generalize better.
I
The
think you
the
could
hinge one
generalize
would
pretty
be more
well.
useful. Like the abstract hinge one would be more useful in kind of a novel situation with a novel object, whereas
I
the
don't
other
know
and I
if
ones
think
give
that's,
you
it
I don't know
more
if
doesn't
that's
more
necessarily
precise
true.
work.
predictions.
I don't know if
It's basically like more general morphology of models versus
I'm
more
not
specific
sure.
ones.
I would think the opposite. I would say if I see some new hinging behavior, I'm going to try to map it onto one of the ones I've learned before, and I'm going to use that for prediction. Because not all hinge behaviors are the same, right? They're
Yeah,
different.
if
They
you
have different.
can.
Right. Well, that's it. Maybe that's all I do. And that seems like, the nature of things. I see something, I'm going to initially say, oh, I'm going to try to interpret this based on my prior learning. My prior learning is that this is going to be like something I've seen before. And if it's not, then I'll learn a new behavior, as opposed to saying, well, there's a base
How is a
behavior.
hinge not something you've seen before?
I've seen lots of hinges. They're not all the same. They all behave differently.
Right.
You look, you might think they're the same, but they're really not. Everyone has where's the pivot point? What's the size of the thing it's moving? There's a ton of differences between these things. We just said, oh no, they're all the same. It's a hinge, and I'm questioning that. I'm just saying, I don't think that's right.
I mean,
Maybe
I
it
agree with
is.
that. I
I
just
I guess I just don't.
I feel like
I would
it
rather.
makes the most of the thousand brains concept of
Uh,
having many models that
uh,
we would have some that are more
but all
specific and
right,
some that are more
maybe
abstract.
you can think about that. I don't want to do that way. I think I'm open to it, but to me, the right way to think about it, the way I want to think about it, is not to have different levels of these things. I just have one mechanism that works in all cases, and the mechanism is I've learned a behavior with specific objects, and those behaviors, even though they both all have hinges, are very, very different behaviors. We think, oh, yeah, they're hinges, but they're different. And now when I see a new object, I'm going to try to infer it as one of the previous ones I've learned. That's my first assumption. And so I might say, oh, this thing, maybe it's a stapler. Or no, actually, no, that looks like it's a door. Or no, it looks like it might be a book. Um, and then I'll see if that works or not, as opposed to saying, well, it doesn't work as a book, so let me apply my default hinge to it. It's like, well, why? It's just like, no, the world is full of details. I want to model those details. I don't, it's like I don't know. It's like I don't have a
Yeah, I mean, I
I
think
don't know.
I think it's worth
it's
exploring. I mean, I would only be convinced like once we have actually fully explored and saw that like it actually checks off everything. I mean, there's very, very likely
Right.
case that like we think about it for like a month and then realize, oh, actually this would not solve
Well,
something
would you
fundamental and we need
agree?
to.
Would you agree with my challenge that the drawing you drew there, which I'm not. I mean, I drew drawings like that too, OJ. So don't. I'm not being critical of it. But
No
I've come to
worries.
believe that simple idea that, oh, there's two things that pivoting on a point is not correct anymore. It's like, no, there's structure there, and it really matters what the rest of that structure looks like. Does it have structure that's similar to a stapler, or does it have structure similar to a door? in which case would be a different orientation, or is it structure similar to a laptop? The physicalness of it, it is not, can't be abstracted away. So maybe you don't agree, because that's what Niels and Vivian are pushing for, maybe that, oh, that does exist like that. I don't think
I'm
so.
not sure. I'm not sure.
I don't
The
think
reason
so.
why I was thinking about that was actually because I was reading some XKCD comics, those like stick figure
Yeah.
comics. And those XKCD, like none of that matches any of our human morphology. Like I mean, we do have a spine, but we don't have it going straight down or coming out, like arm coming out like that. It doesn't even have eyes, and yet we can often infer where the character is looking at, even without the eyeball features being there. And it's just, I feel like, okay, this literal
So,
skeleton of a human, we can infer so much information out of it. Like we
but
can
that's, but
infer,
you're, that's, there's no motion in those images, right? We're doing purely
right?
morphology there,
Yeah.
right? Um, so I'm not sure you can jump to saying the behavioral models
Well,
like
okay.
that.
Actually, I have a one example. I'm not sure if
I
you
mean, obviously people have animated stick figures. Um,
open it
but
again.
again, look at
Is it
that.
possible
Look
maybe
at,
to,
if I saw, imagine I give you just a very, very simple stick figure, and Ian Scott, and it starts moving. I see it as not, I see it as a human. I don't see it as generic hinge behaviors on lines, right? I immediately jump to, it's a human and those are human behaviors, or that's a dog and those are dog behaviors. That's my point. My point is, even something could be very, very simple behavior observed, a bunch of lines, but I'm going to infer it as a particular object. I don't say, oh, generic hinging lines. I say, no, it's human. Now, again, I'm
Right.
talking about behaviors. You're going to show me some morphological things here, but maybe they're related.
Well,
yeah, just
I guess
Jose,
I'm just
if
showing
it's
this
possible
one
to,
because, go ahead. Yeah.
I would just say to maybe clarify a bit kind of how you're conceptualizing the skeleton, like as a concept, because like when you were showing it before with the behavior, so like in the past, I guess we've talked about how, the behaviors can be based on child objects. So it could be a child object moving, and I guess, that child object could be at various levels of abstraction. It could be a specific stapler top, or it could just be like a solid bar or something like that. Or more recently, we talked about like, yeah, with the flow that might be capturing in like a model free way, like an entire object. Um, so is this kind of is this a specific example of a child object, or is this like a new type of feature that's being captured in like a model free way, or is it a different way of representing it in the reference frame?
I'm thinking more, it's more of an abstraction, not correspond to any particular part. Like, this, yeah. And but it's not model free either. So, um,
But so
but
is
yeah,
it would it be fair to say that it would be like a kind of a generic child object, like sufficiently generic that that child object is active for both the top of a stapler and the top of a laptop?
yeah,
Okay.
yeah. Or at least, I said, I mean, at least I put that, I drew them as like relatively like about the same size as like the morphology. And then when we're comparing, let's say I want to look for something else that I can hinge that's not a stapler. A laptop might be a lot bigger, but maybe we might still say that, oh, these are still similar in whatever distance metric, up to some kind of transformation. So if it's just like I mean, we don't think of laptop as like a bigger stapler, but we can see how this and that could be considered similar if we factor out the size, for example.
Yes,
Maybe a way to think about the skeleton, the representation would be to think about it as this is basically just the morphology model in the purest sense as we've thought about it, like without any features attached to it. So it's basically just oriented edges at location. And so, for example, when you look at the stick figures, like in the human, the features would be like arm oriented at this orientation and leg at this orientation. But you could also think of it as like bananas oriented in these different orientations for the lines. And in this case, the object is lines oriented at these orientations. And so the compositional object of these oriented edges makes up the human. And you can still recognize that in the different
Yeah, and where
poses
the
of it.
edges are extracted with a very kind of like low frequency, so that kind of like an arm is just kind of like a single edge or a series of
Mm.
large edges and not kind of the edges of the sides of the arm.
Yeah, yeah. So it's not an outline or a trace, but actual like literally the core skeleton. So
Yeah.
yeah. Anyways, I brought up this one because this one you can clearly see there's like a, even though they're still pictures, you can see that this is a girl kicking a ball with her right leg. And even in a very, very abstract thing, we can kind of infer that, like figure that out. So I was like, oh, like it's, I don't know. But
Is
anyways,
it
that
is it definitely her right leg? I think that's a bistable.
yeah, I don't know. But I mean, well,
But you're right. I
I
mean,
thought it was
we
this
can,
leg. Anyways,
but I
yeah,
mean, I think that's a right answer. We definitely perceive it as being either her right or left leg.
right. I think
Um,
Jeff tuned out. I think it was like, let me just check out of this. Just kidding. Jeff, you here?
I was listening. I just was stepped out of the room for a second. Um,
No.
Back I bought my laptop with me, um,
Okay.
so I was watching all this. I think Vivian's comment. I really like that comment that you know. Uh, I think you made the analogy, if I understood it, Vivian, about that the stick figure is kind of like the higher, the more detailed sort of spatial polar output thing we talked about, and um, and so that in some sense, you know, there's a sort of raw thing that we can see this as a person, and even just a bunch of sticks. And the same thing, and so what we immediately do, we try to match it to something we know. I mean, we just try to say, oh, that's a person. I mean, even doesn't look like a person at all, but we try to do that. And I think the same thing with the behavior. We see a behavior, we try to match it to a physical object. It's like, oh, that's a girl, that's a person. They're kicking something, and or that's someone waving their arm, even just a couple of lines. So I think there's a nice sort of um, parallel construction there, right, between behavioral models and morphological models. Both may be having some sort of more primitive spatial pattern recognition, and but they're, but in all cases, you're trying to infer it to the class of person, or if you don't want to use the word class, but whatever it is, it's like this is in the class of a person. This is in the class of a person kicking something, or you just can't see them separately. You don't see the behavior
What
as independent of any kind of class of object.
Yeah, so what I was saying was actually not related to the spatial pooler. It was about, remember, like several years back, I think when we were brainstorming in person with Rami, we were talking about like the fruit phase and things like that, and how we have the morphology models, which are just orientations at locations, and
Right,
then different features can be associated there as well, like
right, right,
color or object ID. And so in
right.
this case, it would just be the figure and the pose of the figure is defined by
Like
the
you're right, you're right, you're
orientations
right.
at
It could, you're right.
locations.
I
But
went beyond what you said. Sorry about that. So,
yeah, okay, yeah,
right, that could work.
yeah, no
That could
worries.
work too. But I think this guy. Look, by the way, I love the
which the advantage of
XKCD.
is that it's model based. But anyways, sorry.
Whatever. I love the example of the XKCD because it lets us see there's this parallel in my mind. It just highlights the parallel construction between um, simple edges are inferred as a complex object, and simple movements are inferred as a behavior of a complex object. It's they're not just independent. We just immediately try to put them in the class, and it enforces my suggestion, I believe, that behaviors are tied to classes of morphological objects. I think it enforces that idea.
And yeah,
But
just to clarify, kind of the discussion around classes, I think it's not at odds at all with that idea. So, like, it's just saying that, like, in my mind, we already have a solution to classes. Our existing mechanism, it will naturally emerge. It will naturally emerge classes. And then we can just
remind me
use
how
that
that
for what you're proposing. But
remind us how that
yeah, it's
works
not.
again.
Oh, sorry?
So remind me how that works. What do you think our solution to classes is again? Remind me.
So
I,
for example, with the stick figures, you might have a column that only represents orientations at
all
locations,
right,
and it
so that
doesn't
is that
care
idea.
what.
It's just it's the orientation thing that you're talking about. It's still model based, but it's based purely on orientations.
Right, yeah. And it
Yeah,
could have
right,
different object IDs, but the thing that matters are the orientations at locations, and
right, right,
um, some columns might get a higher spatial frequency and represent more details, other
right,
have
right,
lower
right.
spatial frequency.
And
Um,
and again, that's not all classes. Like I think the problem is classes is kind of an overloaded term in, you know, uh it as a
Yeah.
concept. It kind of there's many, as they were saying, like there's many ways that children will kind of categorize things. And I think there's many ways we can say, oh, this is a part of a class with other things. And so it's all going to be using mechanisms that already exist. We're not going to have to invent something new, but I think it's going to kind of lean on different parts of the system, whether it's like, oh,
Well, what is interesting?
this particular column tends to activate for all these things. As far as that column is concerned,
Mm,
these are a class. Whereas, oh, these all things are all associated with this affordance. These things are all a class of this thing.
mm. Okay, I can
Yeah.
accept that.
And
Um,
that's why I kind of separated out the terminology, but we don't have to. So, anyways, yeah.
And I think that's a good thing because it means kind of one less problem. Like,
and I think it will make it easier to do the thing that you're suggesting, Jeff, that like behaviors and morphologies are more tightly tied together because that way you could have more specific models of specific instances that have a very specific behavior tied to it, but then you can have a very general morphology model that with a more general behavior tied to it, like any laptop opening closing versus your specific brand and type of laptop
right,
opening and closing.
right.
Um,
But
yeah,
and
like
are
because
you
that's
okay?
the other thing is like,
Are you but are you okay, are you still arguing there's a generic hinge behavior, or would you are you willing to accept that there may be laptop hinges
I'm willing
and
to
I
accept
staple
that.
mean,
hinges?
more in the
Yeah.
sense that how you described, like if you see a new object, you're gonna try and match it to what's most similar. So you
Yeah.
would match it to some hinge
But
model you have
right,
and predict
right. But if
that.
it doesn't match, then you learn a new one. It's like in
Yeah.
my mind, then it's
Right.
not
Yeah.
generic.
but like
Yeah. I'm
I
on board
think
with
the
that.
problem with breaking it down, or like it feels to me like we're trying then to make it like one level, but I feel the problem with the world is there's always going to be kind of levels of granularity. So, for example, when it comes to laptops, MacBooks kind of famously, when you open them, you don't have to hold the bottom of the laptop down. A lot of non-MacBook laptops, if you just try and lift the top, the whole bottom comes with it. So that is a specific example of a laptop behavior, and so it just feels like that's going to be at a different level of representation.
Why
Um,
would that be different? Why wouldn't I could learn those as two. I mean, you already classified them separate. You said, okay, PC laptops is a different behavioral class than Mac laptops.
I guess it
Why?
just
so
goes down
and
to
then you could learn it as a new example, but also you could also leverage your laptop behavior model. But I guess my point is like you're going to have multiple behavior models active when you're interacting with something probably, and because
Well,
one
of
of
course
those.
you have to infer it, right? You know, you'll see some behavior and you don't know what it is yet. But my point is the inference of the behavior is each behavior is associated with a particular class of physical object. They're not independent of some physical objects. They're tied to them.
Sure.
So, um, I've used both a Mac and a PC, and I didn't notice that difference between them. I'm going to test it now because I
Okay.
don't remember.
So does that mean you on your Mac, do you out of habit always hold down the
Oh
bottom?
well, I was just going to try it, but if I shut the lid, I'll lose everybody. So I was just about to do it. I was like, okay, let's try it. Oh, don't do that. I can't tell. I don't know what I do. But I certainly haven't noticed that difference. I might always hold it and touch it. I don't know. I have to see. Um, Maybe my old Dell laptop was very very thin too. It might have behaved the same way.
Other
But I guess
laptops
the
may have
thing
caught
is,
up. I just know in the 2000s and early 2010s that was
Yeah,
a
yeah,
defining feature of MacBooks.
interesting.
but
so
yeah, it seems like if you can recognize the difference between a MacBook and Intel laptop or something, but maybe you've never opened a MacBook before, but you opened Intel laptops before, and even though you recognize a different brand laptop now, you can apply that behavior to the MacBook.
Right, because
And then you notice maybe it's slightly
right,
different. You might learn a
but
different behavior model, but
but I say it's a laptop. I don't say I'm opening a stapler, or I'm just opening a hinge, or or door. It's a laptop. I expect the laptop like behaviors to exist. Um,
yeah, and so I think that's the thing, that there are different levels of granularity for the classes. One is laptop, which you can do open any laptop if you want, but then you might learn a more specific behavior model for MacBooks where you don't hold down the bottom once you start
right.
interacting with
Well,
it.
I mean, this is. I think I don't know if there's a scale of these things. I don't know if it's on a scale. I mean, we have very specific models, right? My particular mug or my particular laptop where I've learned a great amount of detail on it. Maybe I have another mug I've learned a great deal of detail of. And then there's like a new object that I haven't learned and I have to somehow deal with it. I'm not sure if it's a continuum. It seems to me, feels to me more like I have detailed models and I have classes of models. This isn't the class of mug. This isn't the class of laptop. Maybe I'm wrong about that, but that's what it feels to me. It's like very, very detailed models, and then there are sort of these. I can assume I'm going to infer it is in some class of something I've learned before, and it'll share behaviors with that.
Well,
Like
isn't it much more powerful to have it as a continuum? I mean, you have your laptop, you have MacBooks, you have laptops in general. I mean, it seems like
well,
there aren't just two levels of
well,
classes, and things can be in many classes at the same time, and there can be a
well. Of course,
hierarchy of
of course,
classes.
there can be many classes at the same time, but it's I'm not. I don't know what's more powerful. I mean, I should. There's two ways to look at it. I have a continuum of models from very detailed to very poorly defined models, or I might have neural mechanisms that okay, giving a reference frame, given these features, I will learn a specific model. I will always learn a specific model if I can. But in the process of that, there's a part of the process where there's a more generic version of it. I mean, you could say, for example, that, and then I could. Those are the two possibilities. Um, I'm inclined for the second one that they're sort of like there's detailed models that I can learn more and more details on the very specific objects, and then that there's a different represent or is a overlapping or some of different representations or classes as opposed
You
to
mean
some
in
continuum.
in the same column?
I don't even probably yeah. I mean if, just riffing on an idea. What if the classes were defined by orientations only? Okay, I'm not saying I'm buying into that, but what if it was? Well, then every column has all the orientations, and you can just ignore the details, right? So there you go. Every column has both mechanisms in a single column. I would have
Yeah,
to be
but
able
then like
to.
you don't have the classes anymore that are defined by the behaviors they exhibit or the affordances they have. It just seems
Well,
like we already get classes for
you,
free by the mechanism by
but you argue there's different types of classes, and so I'll accept that. So there's classes based on affordances and behaviors, and there's classes based on morphology. So that doesn't make it a continuum. That just says in a behavioral model, I have also classes, and in the this is a specific behavior of my particular stapler, or this is more of the generic stapler behavior. It doesn't
yeah, I
mean
mean,
there's
I just feel like there's no need to add a separate mechanism because with our existing like setup, we already get classes for free. They will already emerge naturally in the
well,
different columns. So
but there is a
and it will be
different.
nice to
But
continue.
if we're using the orientation idea, right, to make a class, to me that's a different mechanism than the specific locations. I mean the specific details. It's like saying I'm going to ignore the details and just stick to orientations. So to me, there's not a continuum there. That's a separate thing. I can infer from one or the other. Um, I don't
It
know.
might be like a column that only receives orientation or oriented edges as input, or it
Well,
only has.
every column is going to get every column, as far as I can tell, is going to have a mini column representation, which is which mini columns are active, and then there can be very specific instances of those mini column activations, and that's going to be unique SDR. Um, and so the specific instances are always some sort of context. But I've come to, I haven't talked about this, but I've come to understand that, like, if I look at what a column basically says, I'm going to create a unique instance of this mini column, this representation, and then all it can do is associate context with it. A context could be a child object. Context could be anything. It's just the thousands of synapses on those layer 4 cells are just some context to help me figure out which one of my layer 4 cells should be active at this point in time. Well, I would, I don't know. I would suggest, for me personally, this would be a good point to stop.
Yeah, I
If you
guess
don't mind.
Rami. Yeah, I just thought Rami. I think you were trying to say something.
No, Vivian
Oh,
said exactly what I wanted
Oh,
to
you're
say.
happy? Okay.
what were you gonna? What was
Um,
that one? I want to
I
know.
think
I
Oh,
same.
want.
Vivian covered it. Yeah, it was about just that we have you can recognize the different morphologies, but you assign the same behavior to all of them, and some morphologies can be slightly different, and it just feels like we do have different levels of abstraction for how we like. If we want to generalize something, we remove some features or aspects from it. So if we want to generalize like a hinge behavior, I know you're saying that there isn't a hinge behavior, but if something opening and closing, uh, if we want to generalize it to just at the level of laptops, we are going to remove the variabilities from the laptops that make it
Maybe if I
inapplicable.
if I if I think about them, I have multiple mugs where I can't say, "Hey, remove these features," and now I have something in common. I'm not sure I can do that. Um,
Well, that would be the skeleton that Jose is talking about. It's like
right, right.
you're narrowing it down to just a
Well,
bunch of.
I was arguing that the skeleton can't be that minimal as Jose showed it. It feels like it has to be tied to more physicalness related to it. Well, I
Right,
think,
like a higher level, a mark is just like a cylinder with a handle relative to it at a location. And
yeah.
so many cylinders could be that, like many handle shapes could match that.
But yeah,
Well,
but
I
I
think,
feel like we've argued this like the
right.
point sufficiently.
Yeah.
So I think yeah, maybe what you're
Yeah.
suggesting, Jeff, is we just kind of leave it for the
Right.
moment.
And right. And I want to try to, I think to me to be happy, I want to work at some of the other topics I talked about. Like, I'd like to understand how this relates to attention and attentional windows. Because I think that's going to play an important role in any solution. So maybe that's a good way of putting it. It's like we've argued about these individual things a lot. I don't think we've come to an agreement about them. I'm not happy with the answers we've come up with. But maybe by expanding it out to trying to solve multiple ones at the same time, you might come up with like, oh, different ways of thinking about the problem. Um, and so I think attention is one of those things that I think could really make a difference here. Um, I also would like to understand, how we recognize words without seeing the letters. Um, how's it, who's learning to do that, et cetera. So,
I have
uh,
a question about the suggestion of detecting the movement of one object, and the behavior, just detect the whole movement of the object instead of just the optical flow or motion fields.
of the child, the thing that's moving, right? Yes, right.
Yeah, so um, are we saying that this is a single, so is the reference frame staying as it is, with we're just storing the same thing exactly at multiple locations? So it's still capable
That's a
of.
great question. And I think that's, to me, when all this flooded through my head when Vivian suggested this in Milan, it flooded through my head like, oh, you guys might remember I stopped for a second. I just thought in concentration because all this stuff was floating through my head. Like, what does it imply about the reference frame? What does it imply about what does it mean now am I saving the same feature at every location? Or is something else happening?
There's
I
a
don't know
there's a
the
parallel in morphology where we store the object IDs at the same location in a
right.
compositional model. So
Right. And we have this. We also have this issue, right? The compositional one, right. So we're everywhere the child is, we're storing the same data point. Like, oh, it's the child that this ID at this orientation, this ID at this orientation, and that seems like a waste. And then we said, well, we have to sort of extrapolate between them. So we don't want to store all the points. So how do we extrapolate between them? Um, and it would work, but I'm with you, Rami, on this one. It feels like, well, maybe there's something else going on there. Maybe we have to rethink how reference frames work in the context of maybe maybe the dynamic, maybe something else. I don't know. Something's going. It feels like
Yeah, or kind
something's
of
happening
the
here.
features at regions kind of thing
Right,
we sometimes talk about.
right. That little suggestion opened up a whole can of worms in my head. At least the potential for a whole can of worms. It's like, oh my God, maybe there's a lot of things going on here we didn't think about. It's not
If the
right.
higher level is getting input directly from the thalamus, then it feels like the locations they still have to be at the kind of like the same resolution um, uh, of some
Well,
sort of like, yeah.
one thing I started to do, which I'm not prepared to present here, I started making a pictures which showed, okay, what if I assume that this is the area of a if I have a location in a reference frame, there's some sort of fuzzy area which it represents. And now I have an intentional area, which is in theory much larger than that. And then I have, uh, you know, um, and then I have multiple regions which have different sizes in two hierarchical regions. Ones have different size of location, but they have the same attentional area as the lower region. And trying to think of what would happen in these scenarios. I was throwing out ideas like trying to answer your question, which is like, what's
Yeah,
going on? Are we saving all these points redundantly? And because the suggestion that Vivian came up with says that makes no sense at all now, does it? It's like if I have the same feature everywhere, why am I saving everything everywhere? I don't know. It's just weird.
yeah. It challenges
But
the location by location uh, basis.
Or maybe it challenges our notion that reference frames are static, or maybe something else. I
Or
don't.
maybe it can help get us closer to what we've kind of wanted them to be, which is like not this like infinitesimally small point with
Right,
a
right,
feature and then another
right.
infinitesimally small point,
Right. They could
which has
still,
always been a bit
that's a
awkward.
good, well, I've never seen it as points because I know that the cells are not like that, right? If you start moving a
And
little
to be
bit,
fair,
this,
yeah, we don't
right.
treat them as points either because
But,
we have kind of a radius to them, but it's kind of abstract.
conceptually we think of it that way, right?
Right.
What if you could still, I don't know, maybe the reference frame, because we don't really know, no one really knows how grid cells work. There's all these pieces, but it's very confusing. And is it possible that as you move through a reference frame, the point of center of this thing changes, but the area of the field that it represents, it gets larger, something like that. Um, Maybe that's dynamic, so you're not throwing away the whole um, uh, path integration, motor vector type of thing. You're not throwing that away, but somehow there's a variation on top of that that might work. I don't know. It's weird.
we're also kind of assuming that the patch is centered on the child object that's moving. So if we're just saying, oh yeah, it's moving in this direction, like we might still be at the edge of the bar that's moving in that direction, or we could be on the center, and then depending on that, we'd want to put the region in different places in the reference frame.
Right.
Right.
All right. These are all, I think these are a bunch of, we're bringing up all these sort of issues that, again, I think might have a common or largely common solution that might involve one, two, three changes to our conceptual thinking about things. We may have to add several things at once, and then now it all becomes clear. Maybe that's what I'm hoping for.